Alright, so we're going to demonstrate how to implement array sorted list or ordered list. And this implements the iList interface. So we're going to first implement the int size, so return the size. We're going to make it return the num element, which we're going to declare number of elements. First initialize to 0. And we're going to make this private attributes. And then this is an array order list. Of course, we need to create a constructor, right? For array ordered list. Actually, let's initialize num element inside the constructor, because there's a point of using constructor to initialize the values, right? And we're going to need an array because this is an array. So we're going to declare an array of t, and this is a list. If we want, we have to say ordered list. Now we're going to initialize the array. Now array need to specify the size. We can make like default cap, like default size. So make it a private final as a constant int default cap equals to 100. So starting with the size as 100. So this is going to initialize an array of default cap new, and this is going to be an array. Alright, so and this is t type, an array of t type. We have to cast this new. We don't know what the type, so it's object and we cast it, right, as the cap, and we cast it to t array, right, default cap. And this is an array. We have to use the square bracket. Alright, so now we need to create the syntax is the default constructor. We need another constructor in case the users want to specify the size, right? Like size of array. Okay. So this is going to be array size instead. Now we said our has to be unbounded, mean an array, if we do this way, it's going to be bounded. We need to implement a large, right? By whenever we add, we first check what happened to this num elements. Element E. So we're going to say, first we're going to check if the array is full. How do we check that? If pretty much just get a size of your ordered list dot length. If it happened to be equals to the num elements, so we can do size, which is get the size, right? Return num elements. That means it is full. Then we will call the method to enlarge the array. So this method has to be implemented, right? So let's implement, and it has to be private because it's only used inside here. We don't want the one instantiate the array ordered list to use enlarge. enlarge. Private enlarge should enlarge returns, or let's now not return, just enlarge array first, because we already have array, right? Ordered list. Now we need to that arrays and attributes of this class. We can just do equals to. Once it's done at the end, it's going to be like order list equals to the larger list. Now we have to create a larger list, which is an array. Alright, so an array of t larger, and this is an array larger list. So we creating the array which is larger. Now we need to specify the size equals to new. Alright, the size of an array. And this is a t array. We don't know the type, we have to cast that back in order to define array. So we just do object type with the specifying size. Now what should be the size here? It depends on the logic. In the textbook, normally they use just double the size. You don't have to. You can do like increment by 25% or 10%, which is good in terms of memory, but bad in terms of you have to keep copying every time. So depending on the data size, if you know, then this will be beneficial. Now we're going to make it like double the size, which how to double the size? We already have the decap, so that's why we have to look at original size, right? So we're going to declare an original size here as the attribute for the class. Then we can use inside the large method int original size, and we initialize original size to the default cap for the default constructor, but for the size specified, we just do it this way. Now enlarge, we're going to create a new object with the original size plus, if we want to double, just do 2 times. So we create a larger array now. So this larger array, we will need to first copy, right, iterate. We create an array, copy of the contents from original array, which is named ordered list. So int I equal to 0 and I less than the size of that original list, which is ordered list dot length I plus plus. So we start to loop in order to copy this into the larger list, the new array at index 0. So we're going to copy all the contents from ordered list at the same index. So everything has been copied. So after we copy, then we just specify larger list equals to ordered list. See if we're missing anything. So enlarge, create a larger array, double the size, iterate, copy, and return back. So that's good, right? Now enlarge being called when we add. Alright, so now we are ready to add elements. So of course at the end we're going to do num elements plus plus. How do we add? And how do we add? Like we said, we have to iterate to find a location to add because this is sorted list. So we need to do compare to. In this case, we need to get the location to iterate. So we're going to initialize location equals to 0. Right, 4. So iterating for loop int I equals to the beginning, which is location, and I less than the num elements, or we have size I plus plus. So we iterate through the loop to the list. So we start to compare the elements that we want to the element itself at that location. So we're going to name the element itself as the list or the item, something like that, that in the ordered list with specified location from the beginning. So we start to compare now. If the elements, which is the item, this is original element on the list, which is the item, and the item has to cast to comparable, otherwise we cannot use compare to methods. So casting the elements, and this whole thing has to call compare to. What do we compare to? We compare to the element that we try to insert. And after compare to, it's going to return either less than. So if this element is less than, then we're going to iterate. Do plus plus, right? Because it's not the right location yet. So if it's less than 0, then we start to do location, change the index plus plus. Right, but if it's happen to be equals or greater, equals, that means we found it. We found the right location. Equal is only happen when order is duplicate. I mean the list is allowed duplicate. In this case, if we have non-duplicate, it will never be equal, it's just greater. Right. So either way, this logic will support both. So we break out, we don't need to iterate anymore. So since we don't need to iterate anymore, we found the location. Now we have to shifting, right? So this logic is search for location to insert, right, the new element. And now we have to find a logic, right? Logic to shift, right? Shifting. So what do we shift? We're shifting the elements that is greater than. So how do we shift? We have to start from the end. In I equals to, the end is the num element. And as long as I greater than the location, we just do increment I. And then we start to copy the rename ordered list at the I. We should say we copy at the end to the one before, right? To the one before. That's how we copy. And then we replaced the original one back.